So we're going to start by reviewing what it means to factor. So to factor means to write as a product. So to factor means to rewrite as a product. So if you were asked to factor just a number, you would rewrite that number as a product of two other numbers, three other numbers. So if it says factor 36 in 4 different ways, one way is 1 times 36. Another way is 2 times 18. Another way is 3 times 12. And a fourth way is 4 times 9. And so I've taken the number and I've rewritten it as the product of 2 other numbers. How do we factor if we have variables? Well, there are several techniques for factoring that we're going to review. If some of these are completely unfamiliar to you, then you will have to practice them more than others. The first thing you always do when you factor is you look for what is called the greatest common factor. And the greatest common factor is the number. There could be just a number for the greatest common factor, or there could be a number and variables. If it's the number, then you're looking for a factor that is common to both numbers and the largest factor that is common to both numbers. Variables, you're looking for how many of the same variables each term has. So let's look at the first example. Does the expression have a GCF, a greatest common factor? So we'll begin by looking at the numerical part. There's 2 terms here separated by a subtraction. We have a -3, we have a -6. So we know that the factors of 3 are 1 and 3, and the factors of 6 are 1, 2, 3, and 6. And so what do they have in common? They both have a factor of 3. And so the GCF numerical part will have a 3. When your first term is negative, it is standard to pull out the negative as part of the GCF. So I'm actually going to write -3. Now I'm going to look at the variables. So I see that the first term has 2 x's. So I'm going to go ahead and write 1, 2. I'm going to expand. I see that the second term has 1x. So there's the 2, there's the 1. What do they have in common? They just have 1x in common. So I'm going to write an x next to the -3. Then I'm going to look at the y's. I see that the first term has 3 y's. So 1, 2, 3. So I'm expanding the product y cubed as y times y times y. The second term has 4 y's. 1, 2, 3, 4. How many do they have in common? Well, they each have 1 in common, and then they each have a second one in common, and then they each have a third one in common. And so the last part of the GCF will be y to the third. As soon as you write the GCF, you're going to put parentheses next to it, because the parentheses tells you what's going to be remaining after you factor out the GCF. Now, what is remaining? Well, here's how I do it. I take the original term, so I come over here to the side. I take the original term, -3x squared y cubed, and I divide by the GCF, -3x y cubed. So I take the original term and I divide by the GCF, and that leaves me with an x. And then I take the next term, -6xy to the 4th, and I divide by the GCF, -3x y to the 3rd. And that's going to leave me with a 2, because -6 divided by -3 is 2. X divides x is 1. Y to the 4th divides y to the 3rd is y. After you factor using the GCF, you should do a mental check to make sure that you're correct. And you do that by redistributing. So negative 3xy cubed times x is going to give us negative 3x squared y cubed, which is precisely the first term. Negative 3xy cubed times 2y is going to give me negative 6xy to the fourth. That is factoring with a GCF. So the first thing you always do when you factor is you look to see if you have a GCF, whether it has 2 terms, 3 terms, 4 terms. Even sometimes it will just be a numerical GCF, but that should always start your factoring. It will always lead to an easier process after you take out the GCF. Second, you're going to count the number of terms that you have after you've taken out the GCF, and you're going to choose one of the following. If it is 2 terms, you've got 3 choices there. Maybe it's just a GCF, like the one we just did, and what's left over inside, x plus 2y, does not continue to factor. Maybe you factor out the GCF, and you're left with something called the difference of perfect squares. Or maybe you factor out the GCF, and you're left with the difference of cubes. And also this could be the sum of cubes. So the sum or difference of cubes. The sum of squares does not factor. So the sum of squares does not factor. So x squared plus 16 does not factor, as opposed to x squared minus 16, which does factor. That factors into x plus 4, x minus 4. So the difference of squares pattern looks like this: a squared minus b squared, and that will always factor into a subtract b and a add b. And you can flip those if necessary. But x squared plus 16 does not factor. So the sum of squares does not factor. The sum and difference of cubes is a specific pattern, and I will go over that in a second. Okay. What if it's 3 terms, right? Well, you can again begin with GCF, and then after that, you're looking at the type of trinomial that it is. So is it an x squared plus bx plus c, where you have a lead coefficient of 1? And if so, then it factors into 2 binomials. And remember our pattern, these 2 numbers have to multiply to c and add to b. If a is not 1, and so your trinomial is ax squared plus bx plus c, then when you factor, you have to use a process. There's many processes. Trial and error, split the middle. There's a bunch of different strategies. So I'll show you 1 or 2, and you'll have to pick which one you want to use. 3 terms, it could also be a perfect square trinomial. And perfect square trinomials are special because the first and the third terms contain perfect squares. So a perfect square trinomial, ax, hold on, ax squared plus bx plus c, a and c will be perfect squares. B is going to be equal to 2ac. That's the pattern for a perfect square trinomial. And again, we will practice these. What if it's 4 terms? Again, always begin with the GCF. And then what happens is you will look to see if I can factor it by 2 and 2 or 3 and 1. And that is going to depend on the type of terms that you have when you're looking at them. So again, let's go ahead and start some of this. I will go ahead and put down the sum and difference of cubes patterns, but again, we're not going to work on that pattern until we get further down. So the difference is a cubed minus b cubed becomes a minus b, and then a squared plus ab plus b squared, and a cubed plus b cubed, very similar, a plus b, a squared minus ab plus b squared. All right, so let's try some examples. Two terms. Under the two terms, always begins with GCF. So I'm looking at the 3 and the 6, and I know there's a GCF of 3, x squared x, 1x in common, y squared, 1y in common. How do I know what's left in the parentheses? I divide. So I take 3x squared y, I divide by 3xy, 1x remains. Minus 6 divides 3 is 2, x divides x is 1, y squared divides y is 1y. You have two terms left inside. That does not factor. X squared minus 81. So I'm going to go back up here. It's two terms. There is no GCF. Is it the difference of squares? In order to determine that, is the first term a square? Yes, x squared is a square. Is the second term a perfect square? Yes, 81 is 9 squared. And so therefore we follow the pattern by square rooting each of the terms. So the square root of x squared is x, and the square root of 81 is 9, and you put 1 subtract and 1 add, and the order doesn't matter. Two terms again. Is there a GCF? We have a 9 and we have 121. So let's look. Does 121 divide a number that also 9 divides? So 121 divided by 3, no. 9 and 121 are perfect squares. And so we will apply the difference of perfect squares pattern. So we will square root 9x squared. That will give us 3x. So we will square root 9, that gives us 3. We will square root x squared, that gives us x. We're going to square root 121, that gives us 11, and square root y squared, that gives us y. And again, 1 subtraction and 1 adding, and the order doesn't matter. All right, number 4. This one, the first thing I know you want to do is you want to do x plus 2 squared, and you want to multiply that out. But I want you to think of it differently. I want you to think of this as a squared, and this as b squared. This is a different way of thinking about the difference of perfect squares, because x plus 2 quantity squared is a square and 16 is a square. So in order to apply the difference of perfect squares pattern, we will have to square root x plus 2 squared, and that's going to give us x plus 2 minus the square root of 16, which is 4, and then x plus 2 plus the square root of 16, which is 4. So think of this as being your a minus your b, and this being your a plus b. So there's your pattern. It's still there. Go ahead and simplify. X plus 2 minus 4 is going to be x minus 2. X plus 2 plus 4 is x plus 6. All right, we have two terms again, right? But this time we have a cube. We have a cube. A cubed plus b cubed, or a cubed minus b cubed. Well, this is going to be a cubed plus b cubed because of that plus in between. Now, in order to apply that pattern, if you look at the pattern, you see an A and a B in the pattern. In order to determine what they are, you have to cube root A cubed and B cubed. So we have to look at 27x cubed, and we have to cube root it. So what we're looking at is what number multiplied by itself 3 times is 27. And what variable multiplied by itself 3 times is x, because that's x cubed. And so it turns out that A is 3x. For B, you're thinking what number times itself 3 times is 125, and that's 5. You can also utilize the cube root button on your calculator. Right now you're just inserting these into the pattern. So A plus B. Okay, and then if you go back up, you see that it is A squared subtract the product of AB. So A squared. So that means I have to do 3x and I have to square it. So that's 3x times 3x, 9x squared. Then I have to multiply the two together. So 3x times 5 is 15x and subtract it. And then I have to add b squared, and that's 25. And that is applying the pattern. And that's a pattern that you just have to become familiar. You can have it written down wherever you want to when you're working on it, and when you're taking your quiz, you can have it written down, okay? Number 6, let's see if there's a GCF there, all right? So I'm going to do 192, and I'm going to divide by 24, and I get 8. So I'm going to take out a 24 here as my GCF, and I'm going to get a cubed minus 8. Now I see that I have the difference, meaning the subtraction of 2 cubes. So let's pause for a minute and let's think about what numbers are cubes. So 1 times 1 times 1, 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. So those are the perfect cubes. I would write those down so that they are recognizable for you, so that you'll see the difference of cubes patterns or the sum of cubes patterns. All right, so I'm going to bring down that 24. A cubed minus 8. I need to determine what A is and what B is. A cubed, if you cube root that, you get A. And if you cube root 8, in other words, what number times itself 3 times is 8, you get 2. Now we have to finish the pattern. So I'm going to run out of space there. So actually, I'm going to go back and write it down below so I have a little more space. So that's going to be 24, A minus 2, right? Follow the pattern. Square A plus, multiply the 2 together, 2A, and then square B. So A cubed, meaning that would be A, and B cubed. So that's A cubed, and that's B cubed, right? And so that means A is A, and B is 2. And that's how I knew what to put into the pattern. All right, that's a bunch of examples on 2 terms. Now let's move on to examples on 3 terms, all right? Again, always begin with the GCF. So the GCF here is 2, and we're going to have x cubed minus 2x plus 3. So 2 is in common to all 3 terms, and that's it. Number 8, x squared minus 7x plus 10. We've gone over a bunch of those. We needed to practice our factoring when we were solving our nonlinear systems. So x goes here and here, two numbers that multiply to be positive 10 and add to be negative 7. So subtracting 5 and subtracting 2. And then for number 9, why don't you go ahead and try that one? So two numbers that multiply to be 63 and add to negative 16. So that's going to be minus 9 and minus 7. And you can also write it, of course, x minus 7, x minus 9. Okay, what to do when a is not 1? So you see in number 10, number 11, and number 12, we have trinomials where a is not 1. That's this one up here, right? I'm going to show you the method that I prefer. First of all, you can always do trial and error, all right? You can always do trial and error. Trial and error looks like this. You're going to write down both of the binomials, and you're going to follow these patterns. The first two terms will always multiply to be 6x squared. Well, that gives you a bunch of options. You could have a 3x and a 2x, right? You could have the 2x here and the 3x here. You could have a 6x and a 1x, or you could have a 1x and a 6x. Okay. Now, what about in the second position? Well, it's a minus 12. And so what goes there multiplies to be a negative 12. Well, there's so many options. You could do a minus 4 and a positive 3, right? You could do a positive 4. You could do a minus 3. And you could do that in every one of those instances and have all of these multiple options, right? And so this is why it's called trial and error, because you set it up and then you mentally distribute and see if you're right. So let's look at my first one. So 3 times 2 is your 6x squared. Outside terms are going to give me a positive 9, right? Inside are going to give me a negative 8. And the last are going to give me my negative 12. So I'm just going to go ahead and take away these for now while we're testing the one that I have right here. So if I go ahead and test, when I mean test, I'm like mentally doing my distributing. So 6x squared plus 9x minus 8x minus 12. That gives me 6x squared plus x minus 12, which is super close to the one I have, right? Oh, so what if I change the sign and I do 3x minus 4 and 2x plus 3? Now let's try that one. And if you're doing it on your iPad, it's super easy for you to guess and check or trial and error. All right, so let's try this again. So that's going to be 6x squared plus 9x. Oh no, I need to undo that. I need to change the sign. That should be a plus. That should be a minus because it was just the same one I just did. 6x squared minus 9x plus 8x minus 12. 6x squared minus x minus 12 is exactly what I got. So, guess and check is truly trying, guessing what you think it could be, but provided you're following the following pattern. The first two terms have to multiply to be 6x squared, and the second two terms have to multiply to be negative 12. And other than that, you have to do the distributing. You have to guess the numbers, you have to slot them, and then you have to test to see if you're right. Some people are not patient enough to do trial and error or guess and check. They want to have a direct strategy for what to do. That's what I'm going to show you in the second one. And this is There's many different ones. Maybe a previous teacher showed you something. I'm going to show you split the middle, which is what I do when I don't want to do guess and check. All right, so split the middle. Is what I call it. All right, so we multiply A and C. So multiply A times C. That gives me 24. Okay, and B is negative 10. Right? So I'm looking for two numbers that multiply to be 24 and add to be negative 10. And so those two numbers are negative 6 and negative 4. And so what we do is we take that middle term of negative 10x and we split it into minus 6x and minus 4x. And so we take this. So I want you to look at this, and I want you to look at this. See how they're the same? But we just split that negative 10 into negative 6 and negative 4. All right, now we're going to do something called factor by grouping. Factor by grouping means that you're going to group two terms together with two terms together. And then, so you're going to factor by grouping. We're going to take the first two, GCF, 3x, leaving me with x minus 2. Next two terms, GCF is 4, but we always factor out the negative when we're doing a GCF. So minus 4, x minus 2. Now what we just did was called factor by grouping. Now I want you to notice x minus 2 in the first parentheses, x minus 2 in the second parentheses. Now this becomes a GCF. So the GCF is x minus 2, leaving 3x minus 4 remaining. That process is called split the middle. It's a pattern. Once you learn it, you'll be fine. If you want to use that. You can also just always do guess and check. All right, let me try number 12. So if I'm going to do split the middle, I need to multiply 15 times negative 8. So my product is going to give me negative 120, and my sum is going to be 14. So the sum is the middle term. The product is the first and the third. Let me just check my work there. 15 times negative 8 is negative 120. All right, so now product of negative 120. Okay, so there's a lot of options for that, right? And adds to 14. So this is where you still have to play around with numbers. So what multiplies to negative 120? Well, 10 and 12. Like one of them is negative. Let's see. So we tried 10 and 12. 120 divided by 20 and 6. Yes, 20 and 6, but we have to have a sum of positive 14, so that means 20 has to be positive. All right, so watch split the middle. 15x squared plus 20x minus 6x minus 8. Now, again, let's look at this. This is this. So I've underlined it in purple. 20x minus 6x is 14x. We just took that 14x and we expanded it into 20x minus 6x. That's why it's called split the middle. Take the middle term and split it so that you have 4 terms so that you can do something called factor by grouping. And that's what we did previously. So we're going to group the first two, group the second two. GCF, the first one has a GCF of 5x. leaving us with 3x plus 4. The second one has a GCF of negative 2. Always pull out the negative, leaving us with 3x plus 4. Not a coincidence that you see that both of the parentheses have 3x minus 4. That becomes your new GCF, 3x plus 4. There was a 5x next to it, minus 2, and that's what goes in the parentheses. And that's called split the middle. If that's new for you, practice it, look at the videos in Delta Math, and keep coming back to these. Perfect square trinomial examples. These are by far the easiest to factor because there is a pattern, and if you recognize the pattern, then it's just straight up put it into the pattern. So a squared plus 2ab plus b squared will always factor into a plus b squared. Always. How do you recognize perfect square trinomial? Well, first of all, look at the first part, perfect square. So the first and the third are perfect squares. So look at the first one. 4 and 25 begin and end the trinomial. So right away, you think, oh, I think it's a perfect square trinomial. Then you do the middle term check. So is the middle term 2ab? Well, if 4 is a squared, then a is 2. And if 25 is b squared, then b is 5. 2 times 5 is 10. Multiply by 2 is 20. A squared, whoops, let me put my black pen back. A squared minus 2ab plus b squared is a minus b squared. So this one would end up being 2x minus 5 squared. So 4x squared, you're going to square root that. You get 2x. So if the first term is a squared and the pattern says it's a minus b or a plus b, you have to square root it. And then 25, you square root it. All right, let's take a look at this one. 25 is a perfect square, 4 is a perfect square. If 25 is a squared, then a is 5. And if 4 is b squared, then b is 2. 2 times 5 is 10, times 2 is 20. It's a plus, so it's going to be 5x plus 2 squared. If it's a plus in the trinomial, it's a plus in the binomial. So go back to the pattern over here and pay attention to that. That's perfect square trinomials, all right? If you don't recognize them, you can always split the middle or guess and check because they will still factor that way, right? All right, what if you have 4 terms? Wow. Factor by grouping, 2 and 2, 3 and 1. So again, just to go all the way back up to this page, now we're on the 4 terms, GCF, and then factor by grouping 2 and 2, 3 and 1. Okay, so let's go back and look at that one. So 4 terms. Wow, we have a negative 6, we have an 8, we have a 14, and we have a negative 10. So all of those are even numbers. They all have a factor of 2. Lead coefficient is negative there, so let's pull out the negative. We have an x squared, an x squared, and an x. So the most they have in common is 1x. Y cubed, y to the 4th, y to the 4th, y cubed. So they have a y cubed in common. So notice I began, even though it was 4 terms, I'm still beginning with a GCF. Okay, what's going to remain? 3x plus 4y plus 7xy minus, plus, oh wait, hold on. That has to be a minus. because 14 divided by negative 2 is a negative 7. And 8 divided by a negative 2 is a negative 4. Okay, 14 divided by 2, negative 7. X squared divided by x, y cubed, y. And then the last one, plus 5 and nothing else. Now there's 4 terms still left inside. Can you do anything with factor by grouping there? No. So we're just going to leave it. So sometimes it's just a GCF. All right, let's look at this one. Anything in common? P, Q, Q, but nothing in common between all 4 of them. And so here we begin our factor by grouping 2 and 2. In the first 2, I see there's a P in common. So P is the GCF, and we're going to have x minus 3y. In the second one, I see that Q is in common. And again, always pull out the lead negative. So minus Q, x minus 3y. All right, let's take a look. So when you're pulling out the GCF, please make sure that the signs are correct. So like in the first one, P was in common. Px divided by P is x. Minus 3py divided by P is minus 3y. In the second 2 terms, if you factor out negative Q, and you always should factor out the negative, you'd have x left, and then 3 divided by negative is going to give you a negative. Now look what's left. We have a GCF of x minus 3y with P minus Q. All right, last one of 4 terms. Sometimes it's 3 and 1. 3 and 1. And these take some practice to recognize. The 3 is a perfect square trinomial. That's going to factor into 2x minus 3y squared minus 25. Now it looks like the a squared minus b squared pattern, because 2x minus 3y quantity squared is a perfect square and 25 is a perfect square. And so we begin our perfect square factoring. A minus b, a plus b. How do I figure out a? I square rooted a squared. So if I square root a quantity squared, I get what's in it. Now, with these, why don't you try some of them using the previous patterns? Okay, so pause the video, try a couple of them, and see if you can get them right, and then restart. All right, so for the first one, we've got a GCF of 5x squared, leaving you with 2x minus 1. The second one is difference of perfect squares. That's going to factor into 5x minus 7, 5x plus 7. The third one is the sum of cubes. This is your a cubed. This is your b cubed. It's a plus, so you follow the plus pattern. That means a is going to be x, and b is going to be 4. So to determine that, you just cube root. So the cube root of x cubed is x. The cube root of 64 is 4. You can use your calculator. Under the math menu, you will see a cube root button. So it's going to be x plus 4. And then the pattern is you square a. It's a subtraction. You multiply the 2 together, and then you square b. Okay, for the next one, I believe right away there's a GCF of 4. So that's going to give me x squared plus 3x minus 280 divided by 4. 280 divided by 4 is 70. And now we have to see, is that going to factor? Are we going to come up with two numbers that multiply to be negative 70 and add to be a positive 3? 10 and 7. X plus 10, x minus 7. That gives you the negative 70 when you multiply, and it gives you a positive 3 when you add. Number 5 is a perfect square trinomial. 36 is a perfect square. It is 6 squared. And so this is going to be x minus 6 squared. Now you might not have recognized that, and you might have just factored it like normal factoring, which is great. You would have had x minus 6 times x minus 6. The next one, perfect square trinomial, because 9 is a perfect square and 16 is a perfect square. So this is 3 squared, this is 4 squared, and 3 times 4 is 12, times 2 is 24. So if you recognize those, it is great because you don't have to do split the middle, you don't have to do trial and error. So that's going to be 3x and 4, and if that's a minus, it's a minus in the pattern. Number 7, no GCF, right? And we can either do split the middle or we can do guess and check. I'm going to go ahead and do guess and check on this one because it's a 2x squared, so that limits my choices for what goes in the first two blanks. So 2x and x, there are no other choices. So now I'm going to play around with some numbers. I'm going to put a 5 here and a 2 here because I know 5 times 2 is 10, and I'm going to put a plus. And now here goes. I'll change colors to do my multiplying. 2x squared plus 4x plus 5x plus 10. That gives me 2x squared plus 9x plus 10, which is incorrect. So I'm going to go to my eraser and I'm going to erase. I'm going to take the 2 and the 5 and I'm going to switch them. And I'm going to put, I'm going to put the 2 here. And I'm going to put the 5 there. I'm going to go back and test it out. 2x squared plus 10x plus 2x plus 10. It's going to give me 2x squared plus 12x plus 10. Again, not the correct. So sometimes when you're doing guess and check, you keep testing and it doesn't work. What else multiplies to be 10? Well, 10 and 1. So I'm going to go 1 and 10, right? All right, let's test it out again. 2x squared plus 10x plus 1x. Wait. Going too fast. 2x squared plus 20x plus 1x plus 10. 2x squared plus 21x plus 10. Check. Yes. Now, you can do a lot of that in your head. So this stuff that I did here in purple, you could do that in your head, right? You don't have to write it out every single time. Okay, number 8, 2 terms. So are they perfect squares or are they cubes? Okay, well, neither one are squares. So let's check to see if they're cubes. 8 is 2 times 2 times 2. 125 is 5 times 5 times 5. So this is 2 cubed and this is 5 cubed. And so I always put that above because it helps me to remember then that A is 2 and B is 5. And then I just plug it into the pattern. So A, 2x minus B, 5. And then the rest of the pattern, and I know the pattern, but you'll have to write the pattern down. So put it somewhere so that it's handy for you, okay? So 2x squared, so that's 4x squared, plus, multiply the 2 together, 10x plus 25. Okay, number 9. Now the number 7 I did guess and check. So number 9 I'm going to do split the middle. All right, so I'm looking for a product of negative 42 and a sum of 19. So I'm going to split the middle term. So 21 times 2 is 42. 21 minus 2 is 19. So it's going to have something to do with 21 and 2. So that's going to be 6x squared. Now watch me split the middle term. Plus 21x minus 2x minus 7. So again, I will underline the purple and underline the purple. 21x minus 2x is 19x. That's why this is called split the middle. We take that middle term, we split it, we go from 3 terms to 4 terms, and then we do factor by grouping. So group those two, GCF, 3x, leaving me with 2x plus 7, minus, always, when you're doing factor by grouping and you get to that second set, always pull out the negative. Sometimes the only thing in common is a 1, because 2 and 7 don't have anything in common. So I'm factoring out a negative 1, 2x plus 7. Now you can see that commonality. That becomes the GCF, 2x plus 7, leaving you with 3x minus 1. And the very last problem, let's see. Oh, we have a perfect square. That's 7 squared. We have a perfect square. That's 4 squared. But we have a plus. And the sum of perfect squares does not.